All right, so let's look at an example where we're actually going to be sketching a dot plot of the data, um, and then trying to determine just from the shape of the distribution what we would expect the relationship with the measures of center to be. Um, and then we'll also make a box plot and maybe show how the shape of the distribution is also reflected in the box plot as well. Okay, so given a data set of a random variable x, without sketching a histogram, predict whether the shape of the data set histogram will be left or right skewed or symmetrically distributed. Now, sketch a dot plot, predict the relative positions of the values of mean, median, and mode. We'll use our calculators to calculate some values, and then draw a box plot underneath using the calculator values. Okay, so here is our random variable x, and these are all of our datums. So what you might want to do is to go ahead and put those into the calculator. So to refresh your memory, with the Texas Instruments calculator, what you want to do is go to the list editor. So here under the stat button, you want to go to the edit menu and choose edit, hit enter. Now, you'll notice that I filled two lists. Why did I fill two lists? Well, if you look at the datums here, we have 113 and we have two 19s. Rather than putting, 113, rather than putting 19 twice, I just said that I've got 19 two times. And then there was 22 occurred twice. So 22 occurs twice. 25 occurs with a frequency of 4. So 25 occurs with a frequency of 4. So list 1 is a list of the unique datums that we got. List 2 is the frequency of each datum. So if a datum only occurred once, I put a frequency of 1 there. Okay. So to save you time, I would suggest that you enter in the data this way. On the NumWorks calculator, okay, where you do this is you do this in the statistics app. So come down to the statistics app and hit OK. And see you've got a value V1 column and a frequency column, N1. So here a 13 occurred 1 time, a 19 occurred 2 times, 22 2 times, a 25 4 times, and so on. So I basically did the same thing with the NumWorks calculator that I did with the Texas Instruments. All right, so we'll get to using our calculators here next. First, we're going to sketch a picture of what this looks like. All right, so whenever you're drawing a sketch, you want to consider, what your minimum value is. Okay, and this list appears to be sorted. So we have a minimum of 13. So I think what I'll do is I'll start at 10. And my maximum is 33. And so I think I'll end my number line at 35. So if I go from 10 to 35, I should be able to represent all of my data. So I'm going to draw a number line here and then do my best to space it from 10. And then I'll do it by 5s first and then 1s. So I've got 10, 15, 20, 25, 30. Oops, why did it do that? So that was 30 and then 35. So 10, 15, 20, 25, 30, 35. Okay, so here now I've gone from 10 to 35. And let me put some increments in between. So there's going to be 4 marks in between. It's a little off. I know I'm a little bit of a perfectionist. Okay, just do your best to put 4 equally spaced marks. There we go. All right, now let's go ahead and plot our data points, or make a dot plot here. So we've got 113, which would be there, right? This is 13 on our number line. We've got 2 19s, so that's going to be 1 there and 1 there. Okay, we've got 2 22s, so 21, 22. That's right here. So we've got 1, 2. And then I've got 4 25s. So I've got 1, 2, 3, 4. Then I've got 2 26s. 1, 2, a 27, 129, 130, and a 33. All right. So let's draw. Let's go ahead and draw. Imagine we took a blanket and we draped it over this shape. It might look something like this. Let me see if I can do better than that. Again, it doesn't have to be perfect, but there we go. All right, good enough. Now, let's think of our options here, right? Remember our distributions. We could have symmetric, right? And a symmetric distribution would have a line of symmetry down the middle and would be the same on one side as it is on the other. Then we would have left skewed. Okay. And that means that the tail is kind of skewed to the left and it kind of falls down sharply here. And then we could have right skewed, which kind of starts out fast and then kind of peters out here to the side. And it looks like we've got something that looks partly between being symmetric and left skewed a little bit, right? It looks like it started to be symmetric, but then some of these values, like 13, actually 13 really started to pull it out quite a bit. So looking at this shape and looking that it appears to be symmetric or slightly skewed to the left, what would you expect the relationship to be between the mean, median, and the mode? Well, remember, if this was symmetric, you would expect them to be equal or to be approximately equal, something like that. Or if it was clearly left skewed, then you would expect the mean to be smallest, the median to be second smallest, and the mode to be largest, right? Mode followed by the median, followed by the mean, something like that. But because this distribution looks symmetrical and maybe slightly skewed to the left, we might see a little bit of both of these when we actually calculate the mean, median, and mode. So let's wait and see what we get, all right, when we calculate those. All right, so let's go ahead and calculate the mean, median, and mode, and dispel with the suspense. All right, so we have our list of unique datums, and then we have a list of frequencies for each of those. So with the Texas Instruments calculator, hit the Stat button, go to calculate, and we want one variable stats. Now our list of unique datums was in list one, at least for me it was. So again, in order to get list one, you can see that for me it's blue. If you have an older calculator, it might be in orange. But because it's in blue, I need to use this blue second button and hit the number one button, and it'll print L1 there. Now, a frequency list is the list of frequencies, and I put that in list two. So I'm going to hit second and L2. And now I can hit calculate. Okay, let's leave that alone for a minute. Let me show with the numworks people. So again, here's all of this. Now to get everything you need, you just need to move over to the stats tab over here on the right. So, you might be in different places on this table. Just go ahead and use the up arrow until the data tab is highlighted. Then move to the right over to the stats tab and hit OK. All right, and so both of these calculators are telling us the same thing. It's just in slightly different orders, okay? So we have the number of data points. There were 15 here on the Texas Instruments, n equals 15, so there was 15 there. On the numworks, we have the 5 number summary. So we have the minimum, Q1, here's the median, Q3, and the maximum. So let's go ahead and maybe write down the median. So we got a median of 25. And let's see here on the Texas Instruments, we got a median of 25 as well. So let's come back here. And we got a median of 25. Let's find our mean. So let's see here. On the Texas Instruments, the mean is the top number. So X bar is our sample mean. That's 24.4. With the numworks calculator, we got to scroll down a little bit. There we go. Yeah, we want X bar. Just get in the habit of, since we're dealing with a sample, we want sample mean. Okay, that's 24.4. So let's go ahead and write that down. Okay, and the mode. Now, the Texas Instruments calculator, if I remember correctly, it doesn't give a mode. Okay, as we look at all these values, it's not giving us a mode. The numworks calculator, however, will do it if we keep scrolling down. Here we go. See, it says mode. We have a mode of 25, and it'll tell you what the frequency was. If there's more than one mode, it'll say like mode 2, mode F2, right? It'll give multiples. So, but here we've only got one. And if we look here at our data, what's the mode? The mode is the value or the datum that occurred with the highest frequency. So here 25 occurred 4 times. So we've got a mode of 25. So what it looks like is the median and mode are equal, and the mean is a little less. So that's kind of cool because, if the distribution was symmetric, we would expect these to be equal. But because it looked like it was slightly left skewed, well, if it's left skewed, then we would expect the mean to be less than the median. And in fact, that's what we've got. So with the values that we calculated, we actually got this, this hybrid of a symmetric distribution and a left skewed distribution with our measures of center. Okay, so here on 25, this was both our median and our mode, but the mean was here at 24.4. So I'm going to kind of draw this out and then come, oops, that's interesting. Okay, So here at 24.4, that was my mean. And both of these were at 25. Okay, so, had we just calculated this first, our measures of center, if we had done that first, we would be able to infer that this distribution is going to look both symmetric and possibly left skewed. And then when we drew it out, we would go, yep, that picture seems to verify these numbers we calculated at the very beginning. But instead, we looked at the picture first, and based off of the picture that we drew, we were able to kind of infer, this relationship. And what's nice is that, based off of this one set of datums, both the picture that we drew and the values that we calculated are telling the same story. And when you've got two different methods of analyzing data and they're both telling the same story, that illustrates validity of your analysis methods. Okay. So that's like a little mini lesson right in itself, right there. This is actually a really important idea, in science. But the other thing I wanted to do is, yeah, this was a great object lesson for this all by itself, but let's tie this to what we learned earlier about box plots. Okay, because we're going to see a very similar relationship here with box plots. So for box plots, we need the 5-number summary. So this one variable stats function gives us the 5-number summary, right? Minimum, first quartile, median, third quartile, maximum. And the numworks calculator also gives a 5-number summary at the very beginning. Minimum, first quartile, median, third quartile, maximum. That's our 5-number summary. So let's go ahead and make a box plot, because we make a box plot from these 5 values. So to make a box plot, what we do is we put vertical bars, and we're going to put it underneath this number line at each of the 5 numbers in our 5-number summary. So we had a value at 13. That was our minimum. Here at 22, this was our first quartile. Okay, the median was at 25. And then the third quartile is at 27. And then our maximum is at 33. All right, so the first thing we do is from the minimum, we draw a line in. From the maximum, we draw a line in. And then between the first and the third quartile, we make a box. And there's our box plot. Okay, perfectionist in me is kind of rearing its head. I want to make this just a little bit bigger. There we go. Okay. So what do you notice here? So remember that between the first quartile and the third, this is what we call the middle 50%, or half of all the datums. Half of the datums are between 22 and 27. And what you'll notice is that this box appears to be closer to the max, but further from the minimum. So kind of the central body of this data appears to be closer to the maximum. And where this middle 50% is, if it's closer to the maximum, this is indicating that we've got maybe a left skewed distribution. Okay. Now it's closer, but it's not like right on it. So we could just say that this is slightly left skewed. Okay. And we would get that from our box plot as well. Okay. So I think this is a good place to stop. I mean, this is a really simple example, but it illustrates a lot of relationships and connects a lot of different ideas together. Um, so much so there's a think, pair, share doing the exact same thing. All right, let me know if you have any questions.